Hey, good morning. This is Mr. M from Algebra Lessons. Today, our discussion here is rational numbers. Rational numbers are numbers of the form P by Q, Q not equal to 0. This is actually the form of rational numbers we need to discuss, or we want to discuss in this particular topic. So before we are moving on to the details, just like the properties, what are the operations representing these rational numbers on a number line, and the very important thing is density property, and how can we compare two rational numbers. We need to know some basics about these rational numbers, how this number system generated already. So that's what we need to know as a basic or a foundation for this particular topic. So our number system starts with natural numbers, and then 0 is added to the system. It becomes a whole number system. Okay, so when we have only natural numbers, it was just kind of from the numbers from 1 till 9. Okay, and when 0 is added to that system, it renamed as a whole number system, and then to that whole number system they added another set of numbers. Those are negative numbers, so we called all together as integers. Okay, with this system of integers we add more numbers, that is called fractions. Okay, we added fractions there, so we called that system as a rational number system. Okay, in your elementary year, that means in your previous standards, you may studied what is the difference between rational numbers and irrational numbers. So I'm actually not going to discuss that more. Because you are already studied. So if we have a rational number system, we have another set of numbers called irrational numbers. So that is actually not coming in this system. Irrational number system is kind of a different system. Irrational. Okay, irrational number system. Okay, all together with this rational and irrational, we called as a real number system. Real number system. Okay, so we should have these basic ideas in mind when we are actually starting a rational number. So basically, rational numbers are numbers which can be expressed in the form of P by Q, where where Q not equal to 0. Okay, I was actually trying to clear my screen. Okay, so everything is clear. Okay, so now we can start. So first, we know that rational numbers are numbers. Rational numbers are numbers of the form we need to use a different color. Okay, numbers of the form P by Q and Q not equal to 0. Okay, that's what the general form of a rational number system. In layman point of view, or in layman's language, any fractions we can call as a rational number. 1 by 2, 3 by 4. Okay, this is the general form of a rational number. But if we considering that as a system, any number starting from 0 or a negative number all positive number, negative number including 0, we will consider it in the rational number system, because we can express any number in the form of a fraction. For example, 10 is a number, an integer, but we can represent that 10 in the form of a fraction, just like putting over 1, that is 10 over 1. So that's a rational number. So when we are discussing the system of rational numbers or simply numbers, we are actually not going to discuss number system. Now we are going to discuss about numbers. Okay, we can discuss numbers. What are the properties? Okay, the very first property I want to discuss with you guys is the commutative property. The commutative property. Okay, commutative property. Okay, if I am considering two rational numbers a and b, I have two rational numbers a and b. So this property stating that a plus b is always equal to b plus a. So when you are adding, this is commutative property for addition. So we are actually discussing only the commutative property for addition only here in this section. So commutative property for addition for rational numbers, saying that if a and b are two numbers, two numbers means two rational numbers, then a plus b is equal to b plus a. And second thing I am trying to discuss with you guys is associative property. Okay, that is a plus b plus c equal to a plus b plus c. So this is what associative property of rational numbers. Okay, so just keep these ideas in mind. One is called the commutative property, and the next one is called the associative property. Okay, keep this idea in mind. Just sometimes in your problems, this will be very helpful tool to complete the problem. So keep this in mind. So that's what we explained the properties. Okay, so now we are actually going to try to study the operations. Okay, the operations. What are the operations, or the shortest way to find the sum or the difference, okay, in between two fractions. This is actually kind of fractions that we are discussing here in the name of rational numbers. So just we are actually first discussing addition. Okay, so I have two fractions, 1/2 and 3/2. Okay, because this is a fraction, if we need to add these two, okay, we can add this. You know the basic rules. If we have same denominator, keep that denominator as it is for the answer and just add the numerator. So 1 plus 3 is 4. Answer is 4/2 or 2. So that is your answer. Okay, if it is a subtraction, what we will do? 1/2 minus 3/2. Same, because we have the same denominator, keep as it is. Then here the operation is subtraction, so 1 minus 3, answer is -2. -2/2, answer is -1. Because you know the rules of sign. Negative divided by, this is a positive number, so negative divided by positive is negative, so the answer is -1. So if we have rational numbers with different denominators, what we will do? Say for example 1/5 plus 3/8. 1 by 5 plus 3 by 8. There is a shortcut for doing this. That shortcut first I'll explain. If you are answering for a multiple choice question, the shortcut will work like this. So what I'm trying to do is I'm just cross multiplying these two. Okay, multiply, and this is the process. So the answer will be 8 times 1, 8. So what you need to do is multiplication. So 8 times 1 is 8. Put the sign in between these two, that is plus. 5 times 3 is 15 divided by 5 times 8 is 40. So this is 23 divided by 40. So this is your answer for this problem. Okay, so this is the shortcut. Okay, the same problem I will do in a different way with some steps, because your teachers will check for the steps that you reach the answer. So I'm trying to do that with a different color pen. Okay, so the same problem, 1 by 5 plus 3 by 8. So basically what you need to do is you need to find the LCM. Okay, 5 and 8, nothing common you can find there. So what you need to do basically is multiply these two, so the LCM is 40. Okay, so write 40 here. So now you need to listen. Okay, basically what I'm trying to do here is making the denominator same. Okay, instead of having those many steps, I just straightly write the LCM here. So that is 40. So now in this next step, be very careful. What we need to do, divide this LCM with each of the denominator. So 40 divided by 5. So what will be 40 divided by 5? Answer is 8. Okay, multiply that answer with the numerator. So 8 times 1, answer is 8. Write that here, 8. Put the sign, plus. Again the same process, 40 divided by 8, that is 5. Multiply that answer with this numerator, that is 15. So write that here. See, now we are reaching the same answer. 15 plus 8 is 23. 23 by 40. So this is the way you can operate a rational number with different denominator. Okay, so that's it for the operation. If it is addition, we can do like this. If it is subtraction, just like a difference is in sign. But while you are handling subtraction, you should be very careful with the sign. Okay, so now we are trying to study how can we represent these rational numbers on a number line. Okay, that is actually very tricky stuff. If you suppose we can start with the problem. If you need to plot two numbers, one is 2 by 3, another one is 7 by 2. Interesting. Just for our convenience, we are actually keeping one more point here. Okay, so first I am trying to plot 2 by 3 here. Very interesting. So if you have such a problem, what you basically need to check is about the numerator and denominator. There are two types of problems you can find or you can see in your question paper. The very first one is the numerator is less than denominator, and the second one is numerator is greater than denominator. Numerator less than denominator. See here, numerator is less than denominator, and here numerator is greater than denominator. So first we can plot the case numerator less than denominator. That is super cool thing. So numerator less than denominator. How can we do that? Okay, what is the question? 2 by 3. Okay, so in this case, numerator less than denominator. Always keep it in mind, if the question is like numerator less than denominator, your point or the number will be in between 0 and 1. 0 and 1. So in between 0 and 1. Okay, keep that idea in mind. Okay, now we know that our number 2 by 3 is in between 0 and 1. Now I am actually discussing only about the positive numbers. I will discuss one negative number problem with the same thing. Okay, so 2 by 3. So we know that because numerator is less than denominator, it will be in between 0 and 1. So we need to plot. Okay, how can we plot it? Okay, before you are going to plot it, you need to check what is the denominator. So denominator here for this question, the denominator is 3. That means you have to split the space in between 0 and 1 into 3 equal parts. 1, 2, 3. 1, 2, 3. 3 parts. Okay. Where should be our point comes? 2. So from 0 count 2 places. 1. So 1 and 2. You can mark that number 2 by 3 here. So the position of 2 by 3 is here. So that is 2 by 3. That way you can mark the rational number with numerator less than denominator. And the same problem, if you have the same problem, negative 2 by 3. Interesting. Always look for this kind of thing. What is the numerator and what is the denominator? Don't consider that negative sign when you are dealing with this rule. Okay, keep the negative away, and without that negative thing. Okay, 2 by 3. So 2 is lesser than 3. So go with the first rule. Okay, so because this numerator is less than denominator, means our number will be in between 0 and 1. Then complete this process and plot your point. Easy thing. And if it is negative, it will come here. Okay, towards left. Okay, what will happen if numerator is greater than denominator? Easy thing. What we need to do is I need to try with a different color pen. So okay, no, okay, we need to make this fraction 7 by 2, 7 divided by 2 into a mixed fraction. Okay, how can we do that? Divide it. So okay, 2. How many times 2 are in 7? Okay, it is 3. 3 times 2 is 6. Okay, 3. 3 times 2 is 6. Okay, what is the remainder? It is 1. So write this expression, this number in the form of a mixed fraction. So first you have to write the quotient. 3. Okay, 3. And what is the divisor and the remainder? Okay, divisor will be in the denominator, so 2, and the remainder will be on the numerator. Okay, 3 and 1 by 2. That is great. Okay, that means we have a 3 whole section and 1 by 2 part. Okay, so where the number will come? So this whole number section is deciding where your number is. Your number should be. Okay, so what is the whole number part? It is 3. Okay, where is 3? It is here. Okay, so that means your number you can plot after this whole number section. Okay, we know that our number will be after this section. Okay, how many part? So now you can use the first rule, numerator less than denominator. See, this fraction is following that rule. Numerator is less than denominator. Okay, so this denominator is representing how many parts are there. So 2 parts. So split this section in between into 2 parts. So it's 1 by 2. Approximately it is 1 by 2. So our fraction is 1 over 2. So 1 from 3. So 3, this one section. So your number is here. So this is the position of 3 and 1 by 2 or 7 by 2. Okay, so this is the way you can plot the numbers on number line. Okay, so suppose if you are just trying to express or plot or represent these kind of numbers, you can simply say, for example, I'll explain with another problem. Say for example, I have to plot 5 by 3. See, numerator is higher than denominator, so divide it. 3 times 1 is 3, remainder is 2, so 3 and 1 by 2. So again 3 and 1 by 2 is coming, so I am actually trying with a different example. 2 over 5. See, here numerator is less than denominator, so what we need to do, so we know that it will be in between 0 and 1, but how many whole parts are there? The denominator is representing how many parts, into how many parts we need to divide that section. 5 sections. So approximately, one moment. Okay, it will be approximately 1, 2, 3, 4 and 5. 1, 2, 3, 4, 5. 5 sections. Okay, 2 over 5. So 1 section, 2 section. Okay, this is the point. Okay, this is the point. So that is 2/5. Okay, so this is the way you can represent a number or a rational number on the number line. This is quite easy. Nothing to memorize. That is the importance, or that's the peculiarity of this kind of sessions. Okay, now we can discuss about density property. This is we have a new name called density. Density is always representing how populated the area is. So here density of numbers in between a particular section. Okay, so we can consider two rational numbers. We can consider two rational numbers, A and B. And B are two rational numbers. The density property stating that between these two rational numbers A and B, there exists another rational number R such that A less than R less than B. So this is what the density property is stating. Okay, then our concern is how we can find another rational number in between two rational numbers. This is quite simple. So basically, if you need to find a rational number in between 2 and 5, in between 2 and 5. Okay, if I'm asking you to find a rational number halfway of these two rational numbers 2 and 5, halfway of half means 1 by 2. Okay, so I'm actually designed one rule. If you have two rational numbers, A and B, and if you need to find out a rational number in between in the nth way, okay, I'm actually generalizing. So find the sum of those two divided by n. Okay, divided by n. That will be the required rational number that you need. So here it is asking halfway of these two rational numbers. So we can try to figure it out. What will be that number? So add those two, 2 plus 5, divided by, because it is halfway, that means divided by 2. Okay, divided by 2. Okay, so this will be 2 plus 5, 7. 7 divided by 2, that is 3.5. 3.5. So 3.5 is coming in between 2 and 5. So we can say that our answer is correct, because anyway 3.5 we can represent 3.5 as 7 divided by 2. 7 divided by 2. So that is a fractional. That's a fraction. So that itself it's a rational number. So this is the way we can find out the rational number in between another two rational numbers, and the property that is, if a and b are two rational numbers and there exists another rational number r such that the third rational number will be less than the second rational number and greater than the first rational number, that is a less than or less than b, that property is called density property. Okay, next time if someone is saying, oh, density property, this is density property, it's quite simple. So finally, just as kind of an information, this is actually not needed for the lower classes. Compare to rational numbers, rational numbers. Okay, comparing to rational numbers or comparing fractions or comparing to rational numbers is actually I'm actually explaining this for the competitive exams. For this we can make some basic rules that will definitely help you. Nothing to memorize. If we have two fractions, a by b and c by d, okay, the fractions are a by b and c by d. So three statements, keep these three statements in mind, but don't try to memorize. Just practice. Through practice you can easily pick it up. Okay, so the first statement is, if a times d, AD is equal to BC, if AD is equal to BC, then A by B equal to C by D. Okay, that means these two fractions are same. Nothing to compare because those two are same. Second condition, if AD is less than BC, AD is less than BC. So what is the result? A by B will be less than C by D. So very easy to compare to fractions or compare to rational numbers. And finally, if AD is greater than BC, so the comparison is similar. A by B will be greater than C by D. So this is the way you can compare to fractions. Say for example, I will show you one example. Say for example, 3 by 5 and 7 by 3. So compare which fraction is higher or lesser. Comparison, you know what means comparison is. So this is A, this is B, this is C, this is D. AD is 9 and BC is 35. So what is here is this is greater. So AD is less than BC. AD is less than BC. AD is less than BC means A by B. That means the first one. The first fraction is less than the second fraction. So that's it. So I hope all of you enjoyed this session. If you really like my explanation, please subscribe my channel for getting future videos. And thank you. I'll come back with another very useful video for you guys. Thank you.